In the words of Louis Pasteur, there are no such things as applied sciences, only applications of pure science, which are related to one another as the fruit is related to the tree that has borne it. A productive and warm morning, ladies and gentlemen. It's my pleasure to extend a cheerful welcome to you all at the International Conference on Recent Trends in Applied Sciences, ICRAAS 2022, organized by Department of Chemistry in association with World Researchers Association WRA. To say we are all thrilled to see you all join in for this need of the hour discussion would be an understatement. Here's a hearty welcome, big and warm to encompass you all. Albert Einstein once quoted, "The whole of science is nothing more than a refinement of everyday thinking. So the important thing is to never stop questioning." Let me take you all through a quick voyage of this galaxy of institute that Maharishi Markandeshwar deemed to be University Mulana is. Accredited by NAC as grade A++ university, MMDU has built its goodwill as the best university of North India with a rich legacy of excellence in research, innovation, and skill development. MMDU incorporates the best of both the worlds by presenting a synergy of curricula from both the UGC model of education and the leading schools from around the world. Quality education is always research oriented and exposure driven, which is what makes MMGU the leader in cross country studies in every possible field. We are all blessed beyond measure to have with us our honorable keynote guests, Dr. S.K. Ashok Kumar, Dr. Pankaj Thakur, Dr. Dipankar Saha, Professor Pritpal Singh, Professor Vijay Kumar Thakur, Professor Adesh Kumar Saini, Professor Bhavna Parikh, Professor Sumit Mittal, Professor S.L. Garg, Dr. Nirankar Singh, all are respected program coordinators, faculty members, and all associated with MMDU family, and a special gratitude for the idea brewer, a philanthropist, a visionary who has been striving for such enlightening causes and bringing this discussion to reality, Sri Tarseem Gargi, Chancellor MMDU Mulana. We are all indeed privileged to have you all come together and join hands for this insightful topic and spread the word among the masses on recent trends and advances in applied sciences. So let us now collect the fruits of knowledge from our very own eminent speakers for and the preceding session chair who have joined us today and made time from their busy schedules and have kindly consented to preside over this discussion. Let me quickly introduce you all with our dignitaries of discussion 4. The keynote speaker for this session is Dr. S.K. Ashok Kumar, Associate Professor, Department of Chemistry, VIT University, Vellore. Dr. Ashok has more than 25 years of research and teaching experience. Dr. Kumar's research focuses on chemical sensors, chemosensors, fluorosensors, synthesis of ionophores, nanomaterials, bioinorganic chemistry, and cancer biology. Sir has been able to successfully secure prestigious research funding, DST, BRNS, DST EMR, NRB, AICTE. He has published more than 70 research papers in reputed international journals of high impact and is also a life member of the professional bodies like Chemical Research Society of India, Indian Society for Electroanalytical Chemistry ISEAC, and Indian Science Congress Association ISCA. He has published more than 80 articles in various peer-reviewed international journals. He has guided 7 students and has published 1 Indian patent. The session chair for this session is Dr. Pankaj Thakur, Associate Professor at Special Center for Nanoscience, Jawaharlal Nehru University, New Delhi. He has also worked as Associate Professor at Central University, Himachal Pradesh, India. Dr. Thakur's area of specialization includes nanomaterials and nanochemistry. Sir was a postdoc fellow at the University of Warsaw, Poland, and Italian Institute of Technology, Naples, Italy. He has more than 10 years of teaching and research experience and is also a life member of the reputed American Chemical Society and Himachal Science Congress Association. He has successfully completed 2 research projects, first being the Royal Academy of Engineering, London, with an amount worth rupees 50 lakhs, and Campania Region Biotechnology, Italy, with an amount worth rupees 21 lakhs. 5 Indian patents filed by Sir have been granted till date. Let us now hear Dr. S.K. Ashok Kumar. Over to you, sir.
Hello.
Hello,
Hello.
sir.
I'm audible.
Yes,
I'm audible.
yes, sir.
Yeah. Okay. Thank you, Mahima, for nice introduction. Nice introduction. And before starting, I would like to convey my thanks to organizer for providing a wonderful opportunity to be a part of this conference. And also, I would like to thank to our beloved friend Harish Kumar for considering my research, okay, to explore at this conference. So, with this brief idea, let us start for the today's talk. So, today's talk is how to share the slide
So there's
through
a
the
share. Yes, yes.
sharing option through slides or share screen.
So if you share your entire screen, we'll be able to see your PPT once you move to your PPT, the main screen.
No, something problem is there in sharing. Can you help me?
Just a moment, sir. I'll get in touch with the backend team.
Hello, sir. Pankaj, sir. Good morning.
Good morning, sir. Good morning. Very good morning.
Yeah.
Sorry
Yes.
for
Ashok,
my interruption. Yeah.
Yeah.
Ashok, sir,
Yes. Yes. Yes.
Ashok, sir, if you click on share screen option, so you'll see slides,
Yeah.
video file, and share screen. So if you click on share screen, you'll be able to do that.
Share screen. Again, the screen strips are appearing, and here share screen. Huh?
Yes, sir. Yes, we are.
But
We'll be. Mhm.
you are able to see my slides.
So far, no, sir.
No. What is the problem? Share my screen. No. I'm unable to
Just
do it.
give me a second.
What are the other options?
So I will be able to do it via this only. Just give me one moment.
Okay.
Ashok sir, I've sent you a message in the private chat. If you can revert to that, please. So can you share your number in this chat window? I will ask the backend team to call you up.
Nirakar. Yeah. Yeah. Yes. Trying. Okay. Mahima, she is helping me.
While we are fixing this technical glitch, can I get my audiences to interact a little in the comment section? So my question that I asked yesterday remains the same. What do you think? Is science a boon or a bane? Has it made our lives easier or has it made it tougher? Can I get to know from the audiences in the comment section, please? I mean, I'm sure everyone has a different opinion or a side to it, so let's hear it from you guys. Meanwhile, can we have Ashok sir and Pankaj sir talk about this? So, sir, what according to
Yeah.
you is boon or a bane? I'm sure you would prefer, talking about it as something which is very, very advantageous, because you guys with your, profiles are there because of science. So, what are your thoughts on this one?
Uh, Maybe I will start. Actually, any science, when it comes with both the things, positive
True,
and negative.
true,
And we just take the example nowadays, this atom bomb or etc. Initially, the invention is always for a good cause,
correct,
definitely. But later on, this mankind goes for negative always. Positive, I think in nutshell, to answer your question, science has made our lives easy, definitely, for sure. We take the example of mobile and how it's changing our lives. The point is on which the scientific community must think is to minimize the negative uses of this
correct,
science inventions.
correct.
And if we don't do it, the negative impacts will come more and more in future.
Very true.
So
I think yeah, sir. Very aptly put.
that's
I think that's the thing. Like you said. I mean, like we say, a coin has two sides. It's on you whether you want to use it positively or negatively. And of course, minimizing the risks is something that is very, very important. And I think
absolutely.
I can recall it from a layman's perspective, since I don't come from science background. I can recall it, that movie in which robots, probably rule the world. So if we make a robot to actually assist a human being, it can be
Abs-
helpful. But on the other hand, if they start ruling, probably they can destroy the human who has actually created the robot. So we
Mhm.
need to keep that whole, definitely. Ashok sir, any thing there? Have you been able to sort the issue?
Nirankar sir,
Ashok
so
sir?
he is giving some help.
Okay.
Yes. I'm just interacting with Nirankar. He has requested my PPT through by email.
Okay.
I already answered the details. Okay,
Sure,
just
sure.
another through by WhatsApp also I'm going to send.
Okay, done.
Nirankar? Yeah, actually in the WhatsApp still it is loading. Now I sent through by email also. Just check it. Yeah, now I think in the WhatsApp also I think the details reach it. Both you can see email and WhatsApp both.
So while we get sorted with the technical glitch, may I request the backend team to play a short video?
पापा ये थोड़ा मेरी तरफ से।
ओ बेटा बाप को पैसे दे रहा है।
अरे नहीं पापा, इट्स जस्ट अ थैंक्स।
किस बात का?
वो आपने कहा था ना, कहाँ पढ़ना है वो फैसला बड़ा होता है। जिंदगी के 4 साल का सवाल नहीं, सवाल पूरी जिंदगी का है।
Maharishi Markandeeshwar deems to be University, Maulana Ambala, preparing you for the real world.
A smile is a makeup that never fades away. And let me guess who makes them? A dental surgeon.
Hi, I'm Deepthi and I'm pursuing my BDS from this renowned university. MMU is a guide map to many national and international students which leads them to their destination named as success.
It's a place where you basically expertise in your area of interest, mainly by focusing on theories. But MMU focuses on both practicals as well as theories.
The core aspiration of College of Dental Science and Research is not only to produce a good dentist but also a good citizen by adopting a moral and ethical value.
Yeah, I am trying to upload through the uploading option. It is just now uploading inside. A little bit advanced, if you told me, I would have tried like this.
MMCDSA comes in the top 25 dental colleges all over India, and I'm very proud to be a part of this stupendous college.
I'm glad I chose MMU as my university, as it provides plenty of opportunities in all walks of life.
Maharishi Markandeshwar deems to be university. Mulana Ambala, preparing you
Hello,
for
madam.
the real world.
Hello?
Yes, sir. Have you been able to sort it?
Yes, Mahima, I just uploaded now.
Okay.
Now
So
now
this
my
is the
slide is
big-
visible.
Yes, yes.
Okay, very
Sir,
good.
it's absolutely visible.
Okay, now
Yes, sir, you will
any
use it.
slide. No, now the slide is in full share mode or only.
Please, it's in full screen, sir. You can see it properly.
Okay. Once again, good morning to one and all present here. So today I'm going to talk on the topic of versatility of organophosphates, phosphonates in molecular sensors. So this is one of the research problem. We took it in 2017, and it took almost 4 years to complete this research. So this particular research work was funded by BRNS to solve some problems associated with thorium sensors. So in this way, these organophosphonates molecules are working, and that particular story I'm going to share it with you. So in this particular talk, I would like to give a brief introduction to about your molecular sensors, and then introduction to organophosphonates, and then I'll move to the use of organophosphonates in fabricating a thorium ion sensors. So these organophosphonates molecules work out for fabricating 3 different sensors. So one of the sensors is in the form of chromogenic, another is in a fluorogenic, and the last one is the potentiometric sensors. So coming to the introduction, this disaster of COVID-19 highlights the importance of demand and challenges of sensor development. So sensor development started long back, but once again it has taken a new shape in this pandemic situations. So in pandemic situation, any sensors which are highlighting for the COVID situations, so those sensors are really a dominating one. So these sensors are really useful for determining the toxic metal ions as well as the disease biomarkers. So all these molecules works out on the basis of this simple principle. So these all molecular sensors consists of 3 basic units. So in basic units integrated in one form. Okay, that molecule containing receptor, the molecule containing a right spacer, and also molecule containing signaling. With the help of these 3 integrated units, we can able to analyze this analyte. So with this simple design, people started to work out long back. So anything you want to work out, nature is already created. If any persons understand that nature things, very easily you can mimic in an artificial system. So you can see here, valinomycin is a well-known antibiotic material which is present in the cell membrane, which helps in the controlling of your potassium and sodium ions. So in particular, valinomycin is meant for the specific to potassium ions. So by seeing these type of naturally available molecules, people started to mimic this in an artificial system. So in this way, these three scientists in 1970, they understand the situations and they come out with artificial receptors. So In the artificial receptors, Patterson created a crown ethers, two-dimensional molecules, and Lane and Cram created three-dimensional molecules. So with this, the evolution of supramolecular chemistry from the Lane side and post-gas chemistry from the Cram side. Yeah, with this idea, we also started to plan that how we can find out a new molecules for the sensors. In that angle, we planned it for organophosphonates. And organophosphonates are one such type of molecules in their structural need. This type of linkages are there. CO, PO, O are functional groups, where that C and phosphorus bonds are very strong and stable bond, while R may be alkyl category, RL category. So organophosphonates are not today's compounds. It is almost used from almost 50 years. If you see the history of organophosphonates, almost all organophosphonates are working very well in our society. You can see here some of the compounds are working here antiviral, and some of the compounds are working as working for the calcium metabolism for bone treatment purpose. And some of the molecules like you are using for the anti-scaling agent, and some molecules like your sequestering agent, particularly in inhibiting a scale forming species. So sometime earlier, long back, people used to use Calgon. Calgon reagent was so popular in removing the calcium from the water and avoiding the scale formation in the inside the boiler systems. Also, some of the molecules like MRI contrast agents. So this type of cyclic pendants used for the MRI contrasting agents. So also people are started to use in the nuclear industry for extracting thorium and uranium. Now this particular molecule, this phosphonate molecules made us to think in a new directions. In that angle, we designed some new molecules. Those molecules I'm going to discuss very shortly. So in this particular project, we quantified one of the analyte, that is thorium. So what is the uses of thorium in the society? A lot of uses are there in the society. It is used long back in the mantles. If you see our lantern mantles, the mantle will be on the nylon fabric materials. This thorium oxide is deposited. When that mantle is heated to around 1000 degrees, it start to kick out the white light. So in such type of materials, thorium contents are also there. Also, this thorium is used as a catalyst in converting syngas into olefins. Also, in the major category, people are nowadays thinking to the next generation nuclear project is nothing but thorium reactors. So all across the world, there may be around 500 reactors are there. In India also, they are going to start some 50 to 60 very soon, maybe by another 3-4 years. So what happens over uses of this type of thorium? So chances are there it may enter into our food chain. So once it enters into food chain, there will be a problem. There will be a problem like maybe a lung cancer, pancreatic cancer. Several type of problems are there. So one has to know, at each and every stage, the thorium contents. So determining of thorium contents can be done by several methods, but doing in a simplest method is the very matured concept, matured thing. So there are sophisticated instruments and also there are simple techniques are also there. But the thing is here that the small amount of determination of thorium by simple method, it's not possible. So in order to work out such a low concentration level of thorium, so one has to go for sophisticated instruments, or one has to go for this type of sensing techniques which are having highly sensitivity. So if you want to go for the chemosensor techniques, we need to prepare a selective ligand. So that is the logic in this type of research. So if you are able to prepare a suitable ligand or suitable receptor, that makes our fulfillment in determining the analyte concentration. So in this angle, we started to think towards how can you convert that phosphate which is used only for the solvent extraction, which is used for solvent extraction for more than 50 to 60 years, how can you convert that molecule into a molecular sensors layer, So in that angle, what we did, this is our tributyl phosphate. One of the side phosphorus is linked to a signaling unit. Only what we have done in this research, we have connected. This is already available. This tributyl phosphate ion is already available. So we removed this butoxy chain and we attached one signaling unit over there. So by making this one, we converted this molecule, which is non-molecular sensors, as molecular sensors. So in this angle, we connected this bipyridine linkage and connected with 8-aminoquinoline, connected with the 8-hydroxyquinoline, leading towards the ligands for the thorium detection purpose. So in order to prepare such type of molecules, already one established reaction is available. That is our Arbor-Sauer reaction. Arbor-Sauer reaction says that this phosphonate reacts with alkali in neat condition. We are going to get a phosphonate. So this particular reaction we have used thoroughly in preparing our desired molecules. So coming to our synthetic scheme of our desired ligands, the story started with like this. We took this dimethylpyridine, dimethyl bipyridine, converted into its corresponding halide after treating with N-bromosuccinimide, and this alkyl halide reacted with the tributyl phosphate in a neat condition. Okay, there is no need of any solvent is required. Okay, so we got this desired product. So this desired product is denoted as L1, and similarly the second molecule is by taking 8-aminoquinoline reacted with the chloroacetyl chloride in the presence of trimethylamine. In nitrogen conditions, we got this intermediate product, and this intermediate product further reacted with the tributyl phosphide. We got this phosphonate. So this phosphonate is almost mimicking the one of the nuclear extracting agent, that CMPO. So in the case of CMPO, the signaling units are there, but here you have created a signaling unit, that is by using this 8-aminoquinoline unit. So similarly, the third ligand started with the derivative of hydroxyquinoline, okay, subjected to a series of its conversion. At the end, this 2-chloro-8-hydroxyquinoline react with the tributyl phosphide, you are going to get phosphonate. All these phosphonates having excellent yield, okay, excellent yield. The reaction schemes went systematically. So these type of reactions very easily you can extend it to industrial scale-up level also, because the reaction yield is also very, very good. And all these papers we have published in this particular journals. If anyone want to know in depth, if you use this particular paper, they will get all the informations. Yeah, after preparing our desired ligand, what next? The next is we have to characterize as a molecular sensors. So to characterize a molecular sensors, we have to follow these many properties. Minimum these 8 properties we are supposed to adopt. Then only we can able to claim it as a sensor. And to support these experimental evidences, we need to support by theoretical studies also. So for the theoretical studies, we used a Gaussian software and used a methodology of this DFT studies by using this type of basis set and basis set for your ligand and basis set for our thorium. So when you want to use heavy metal ion characterization, we supposed to use this SDDD basis set. So coming to the characterization of our ligand one, that is our bisphosphonate. That bisphosphonate, we dissolved it in acetonitrile and started to characterize through by UV visible spectrophotometer. Okay, so the alone ligand is giving like this, where there is a black line strip is coming. That is our alone ligand. And after interacting with metal ions in acetonitrile medium, it interacted with the ligand, and the corresponding UV visible signature looks like this. Okay, so almost all ligands are coming, almost all metal ions are coming where the ligand is there, while with the thorium it is coming at a separate with a red shift. This all due to because of a proper complexation formation. So this type of outputs definitely shows that that ligand is very selective for that particular analyte. So here the analyte, here it is thorium ions. So further, we subjected to spectrophotometric titration by increasing the addition of thorium contents in the system and taken the several spectrophotometric scans. And when you club together, so we got a isobestic points at several points. The formation of isobestic point shows that there is a formation of new species. And also we checked in what pH region this sensor it will work out. Particularly with the thorium, with respect to this particular ligand, it worked out in the region from the 1 to 4 level. Anything if you are carrying out above 4, so there is no detection. So because above 4, your thorium is undergo hydrolysis, so thereby the thorium contents are going to decrease. Accordingly, there will be a decrease in the absorbance. And also we studied the stoichiometry. So for one ligand, how many thorium ions are combining there to form a complex. So in this way, used a Jobs plot method. This Jobs plot recommending that there is a formation of 1:1 complex. After understanding 1:1 complex formation, what is its strength? How strongly that the thorium is binding with the ligand? That particular study we studied by your BH method, that we call it as a Benzene Hildebrand method. So this shows that the value in the region of 6 into 10 power minus 2. So this is almost a peculiar property for a molecule to behave as a molecular sensor. While constructing a molecular sensors, the binding constant should not be too high and it should not be too low. It's supposed to be optimum level supposed to be there. So anyway, so this interaction shows that a optimum level of binding constant. So after that, we studied the effect of interfering ions. Will our ligand will interact with other ions? Will our ligand will 100% detect thorium ions in the presence of other ions? So for that particular purpose, we studied in the abundance of interfering ions. The abundance may be to the tune of 20 equivalent or 50 equivalent. Sometimes we went up to 100 equivalents. I mean to say that one equivalent of thorium, one part of thorium with 50 parts of interfering ions. In such harsh condition also, this ligand able to selectively detect the thorium ions. So that shows that this ligand is really very selective for this thorium. Also, we studied with the anions also. Whenever you study foreign ion effect, we have to study both cations influence as well as anions influence. Because in the environmental, all sorts of ions will be there. So one has to prove it in the stimulated system that this ligand is very selective for that particular ion only. So after establishing, one has to understand what type of interactions are there. If you get a single crystal of that particular complex, all the problems will get solved. If you are not getting a single crystal of that particular complex, we are supposed to investigate it. We are supposed to investigate it with using several spectroscopic techniques. How that the thorium, where the thorium is going to interact, with which part it's going to attack. All these things we are supposed to understand. For this understanding, we studied NMR spectroscopy, both proton as well as phosphorus, because ligand is having a phosphorus in it. So we are supposed to study phosphorus. So by seeing our NMR, proton NMR spectroscopy, there is no influence. There is no shift in the hydrogen pattern. It means that the ligand it is not attaching to the nitrogen side, because nitrogen wherever the nitrogen atoms are there it is well connected with the corresponding hydrogens. If nitrogen is interacting, then automatically the nearby hydrogen atoms will get influenced. But in this case, there is no such type of changes we observed in the NMR spectroscopy, but there is a change. There is a change in the proton NMR, in the phosphorus NMR spectroscopy. You can see here, alone ligand, it is giving the resonance peak at 25.7, while after complexing, it is showing the shielding effect 23.56. So this change is due to because of the involvement of phosphorus in complexation formation. So this shielding is due to because of the additional electrons are donated from the butoxy chain. And also with this, we will not come to know what type of complex formation is there. Jobs plot already given that 1:1. In 1:1, in what sense we can understand? So for this purpose, once again, we took the ESI mass spectra. The ESI mass spectra gives several species. In one of the species, it is showing that there is a formation of a complex that two ligands ligands interacting with two thorium ions in a side chain manner in the side arms like this it is going to form a complex. So with this particular complex, we investigated quantum chemical calculations, and this quantum chemical calculations exactly shown that the experimental values as well as the theoretical values are coincided. So in this way, this particular work we completed. So coming to the next part, that is the same ligand worked out for the zinc sensor. In a chromogenic manner, this ligand worked out for thorium, but in the fluorogenic manner, it worked out for zinc. So in order to make a zinc sensor, what we adopted, that is, we adopted a polymeric backbone sensor. We prepared a aptodes. Instead of going for a solution study, we prepare aptode. By preparing aptode, we can able to use this probe in 100% water system. In 100% water system, you can see here, this is the your usable signature. While when you take it, it's a fluorogen. When you take it as a spectrophlorimetric performance, only with the zinc we got this fluorescence enhancement. This fluorescence enhancement is due to because of a CHEF concept, chelation enhanced fluorescence concept. Okay, so this is in this way the response came, and systematically we characterize it, and this particular molecule binding studies also studied. You can see in this study the proton NMR spectra, it is showing the variations. There is a change in the proton variations, but in the case of in the case of phosphorus NMR, these phosphorus peaks are remain same. It means that zinc it is not binding through by phosphoryl group. Zinc is only binding through by that pyridyl nitrogen. In pyridy, there are two nitrogens are there. Those two nitrogens only it is interacting with the zinc. That is the way we can by using this particular experimental proof, we can able to make an assessment that with the zinc, the coordinating sites are nitrogen. With the thorium, the coordinating sites are phosphoryl through by side arms. So in this way, this particular molecule worked out. Also, this ligand we use it for the live cell imaging. So live cell imaging. In this imaging, very easily you can find out the ligand, the complex in the intracellular medium. Also applied in the analysis of zinc in the water system. The next compound which you have taken, that is our 8 amino CMP conjugated 8 amino quinoline, and it worked out as a fluorogenic aptode. So in this, with the inspiration of our zinc sensor, same thing we continued with this molecule, and we prepared the aptodes. And this aptode fantastically worked out for the thorium ions. And you can see here, thorium ions we can able to detect up to the level of 256 ppb, or sometimes it may be around 256 ppt level. Up to p50 level, we can able to determine the thorium concentration by using this particular probe. And this fluorogenic probe is operating with the principle of PET inhibiting followed by chelation, the CHEF concept. Alone ligand is non-fluorogenic nature, but after complexation, the ligand becomes fluorogenic nature. This fluorogenic nature is attributed by two key mechanisms. One is CHEF mechanism, and another through by PET mechanism. So similarly, we studied the effect of foreign ions. There is no effect, and also studied through by NMR spectroscopy to make assessment of the binding coordinates. So these assessments are totally guiding us that the phosphorylate are interacting. Here the phosphorylate are also interacting, as well as the proton influence is also there. So additionally, carbonyl groups are also interacting. So after understanding those experimental details, we calculated through by theoretical studies. Theoretical studies are showing that the HOMO-LUMO formations, in the case of this molecule, the HOMO and LUMO are in the same site, while in the case of complex, HOMO is in the quinoxyl, the butoxy chain, while HOMO is forming in the thorium site. The next molecule which you have taken is that is hydroxyquinoline phosphonate. It worked out for the as a potentiometric sensors. We constructed as a potentiometric sensors. But in particular, this molecule behavior in fluorogenic and spectrophotometric, it is very weak. So to claim as a sensor, it is very difficult. So in order to claim this molecule as a sensor, we opted the potentiometric sensor. To claim the potentiometric sensor, the molecule is having a desirable properties. What the desirable properties supposed to be there to make a potentiometric sensor, all these are available with these molecules. With that idea, we started to prepare what liquid membrane electrode. We prepared the liquid membrane electrode with a well-established procedure, and we set up this electrochemical setup. And from this electrochemical setup, we analyzed the thorium concentration, and this thorium concentration fantastically behaved through by a Nernstian manner. And this entire composition is to claim the Nernstian response purpose. So one of the composition where the ligand is around 4% is there, that worked out for the exact quantification purpose. And also the other electrical, other sensing properties we are taken out. You can see here, for all other metal ions, it is showing the response like this. Only with the thorium, it is showing a unique response. And the calibration plot also, it is showing the detection limit up to this particular level. And the change in the pH also, you can see it worked out in the region from 4 to 8. So also this particular sensor used as a indicator electrode. Any electrode, if you are able to use it as an indicator electrode, that makes its robustness. Also, we studied the Fahrenheit effect by using the selectivity coefficient values. If you see all the selectivity coefficient values are high with the positive, that is the welcoming values for with respect to sensor. So also we studied through by SEM morphology. So SEM morphology also helping that how the morphology is changing after the complexation formation. So we studied the binding mechanism also, binding mechanism through by NMR and proton. So also the ESI mass also you are taken into consideration. With all these things, we studied the theoretical studies. So the theoretical studies are also shows that the HOMO-LUMO formation in the case of ligand in the same site, while in the case of complex, the HOMO is forming on the quinoline side and the HOMO is forming on the thorium side. So that shows there is a LMCT concept, ligand to metal charge transfer concept. So all these further evidenced through by calculations. So what the experimental evidences are there, that is well supported with the theoretical studies. So finally, all the sensors are applied to analytical applications. For this purpose, we took two samples. One is monoxide sand purchased from the Indian Rails Limited, and one sample is our gas metal samples. So in the introduction, I already told to you that the gas metal sample containing thorium oxide, and this is our monoxide sand, which is purchased from the Indian Rare Earth Limited. So these two materials are subjected to this particular process to get a thorium oxide, thorium which is in the insoluble to a soluble form, and then checked through by our sensor. So the sensing activity shows that almost what we have detected from the sophisticated instrument, the same value is reported over here. So all these sensors are equally good. So finally, the summary of the talk is that the way that we prepare this ligands demands only simple procedure, and that too without a solvent. Sometimes without solvents. It means that a green approach is there. Also, some of the ligands like L2 and L3, we can use it 100% in the water medium. Any sensor, if you are using in a water medium 100%, that type of sensors are really robust sensors. And if you see the detection limits of all the three sensors, it is very well low only. Low means WHO recommends determination of minimum 60 ppb. So all our sensors are able to measure what the WHO is recommending. So hence these sensors are really robust nature, and this all is due to because of that particular ligand, that is organophosphonate ligand. Organophosphonate ligands are very versatile in nature. We can by tuning its structure, we can able to convert in a different sensors also. We can able to use it in a different medium also. So this is the details of this organophosphates. So with this, I'll stop my talk, sir. Thank you.
Thank you so much, Dr. Ashok, for such an insightful talk. I now hand over the proceeding to Dr. Pankaj Thakur for his comments. Over to you, sir. So may I request you to please unmute your device, Dr. Pankaj? Yes.
Yes, Dr. Ashok, a very nice talk. And what I'm interested more is the green approach for various chemosensor applications. And I have one question regarding your EDS. You just showed after other people go, we go for question and answer sessions. The EDS, which can you go to that slide? You showed this SEM micrographs and EDS. Yes, this one. next one, EDS analysis. Yeah, this very next slide. Yeah. So yeah, I want to see the various next slide, please. Next slide.
Yeah, this slide only containing EDS details. The slide number 26.
Okay,
I'm seeing 26. You are also seeing 26.
Yeah, 26. Yeah. So the point is, I'm not able to visualize these peaks. The highest level of elemental analysis. What is it? Maybe you have showed in next slide the percentage. Yeah.
No. This is selectivity coefficient. Only this is the EDS spectra.
So are you going for some percentage basis of EDS analysis?
No, sir. Here we want to see qualitatively whether thorium is there in the matrix or not.
Okay.
Because
so it's
by taking this EDAX spectra, just we want to analyze qualitatively whether the thorium is bind to our ligand or not.
Okay. So I hope the thorium peak is for maximum. Is that so, or it's for carbon, something else?
No, maximum for carbon, then followed by oxygen, and the last three peaks are meant for thorium. Because thorium concentration is there, it is very, very small. Very, very small.
That's fine. Second query from my side, I'm sorry. How will you support this green approach? Is it because we are involving a lot of chemicals? So one argument in support of it.
Yeah, green approach means this approach are all together we are using in a green medium. In means 100% water medium is using. No need of any other chemicals to detect thorium.
Okay.
In other cases, we need to add some other ingredients. As such, real samples we can contact with this probe, and what the response comes, that response is equivalent to that analyte presence.
So the point is about the solvent is eco-friendly, that's water, and you're not involving any organic solvent. That's perfect.
Yes.
Thank you. So that's all from my side. It's now question and answer sessions. If there are some questions, please let me know from the audiences, or I can see Dr. Dipankar Saha ji is also there. So if he has some question, then we can.
Sir, Dr. Dipankar is for the next keynote session. Okay. And so far, we don't have any questions. So maybe we'll proceed to the next talk.
Yeah, if
Sir,
there are no questions, we
my
can
one
proceed.
last slide is there. One last slide. I would like to acknowledge that yeah. So finally, I would like to thanks to our VAT management for providing a wonderful research facilities to conduct our research, and DST then BRNS for providing a funding approach, and all our collaborators like Brahmananda Rao, all these people are involved in our BRNS project, and Douglas Fox and Subhan Kumar Sahu, they helped for our computational analysis, and our collaborators are Dr. Sushil Mittal is our PhD supervisor. Still he is helping us in one or other way. And Harish Sharma and Nirankar from MMU also, they are also involved in our research progress. And this is the acknowledgement. Thank you, sir.
I think that was a great session. Congratulations, Dr. Ashok, and thank you so much, Dr. Pankaj, for your words of wisdom.
Thank you. Thanks a lot.
Thank you, sir. So let us now collect the fruits of knowledge from our very own eminent speaker 5 and the preceding session chair who have joined us today and made time from their packed schedules and have kindly consented to preside over this discussion. Let me quickly introduce you all with our dignitaries of discussion 5. The keynote speaker for this session is Dr. Dipankar Saha, who is currently serving as the expert member, Ministry of Environment, Forest and Climate Change, Government of India. Dr. Saha was the scientist E at CPCB and has served as the additional director and head, Air Quality Monitoring Division and Infrastructure Division, Central Pollution Control Board, Delhi, and research officer, Sundarbans Tiger Reserve, Canning, West Bengal. Dr. Saha is a former scientist E and divisional head, Air Quality Monitoring and Management at CPCB. He also prepared the emergency action plans for Kanpur and Agra in Uttar Pradesh, and was instrumental in setting up the CPCB laboratory in Kanpur and the establishment of ambient air quality monitoring stations at Agra. Dr. Dipankar is the advisory and nodal officer for implementation of National Clean Air Program NCAP, Bihar State Pollution Control Board, Patna. Sir is also an expert member Environmental Appraisal Committee Infra 2, MOEF and CC New Delhi, and is serving as the reviewer of Indian J of Medical Research ICMR New Delhi. The session chair for this session is Dr. Pritpal Singh, presently working as the Vice Chancellor at Sri Guru Granth Sahib World University, Fatehgarh Sahib, Punjab. Dr. Singh has worked at various administrative positions as Dean Academics, Registrar, Principal, along with a vast teaching and industry experience of more than 31 plus years. He has published around 60 research papers in various national and international journals, has co-authored more than 20 papers and book chapters published in conference proceedings. He has guided 10 PhD and MPhil students. Dr. Singh is well recognized for his prominent participation in a number of scientific exercises globally. Dr. Singh was also the former member, Academic Council, IKG PTU Jalandhar, former member, Board of Studies, Basic and Applied Sciences, IKG PTU Jalandhar, former member, University Calendar Formation Committee, MRS PTU Bathinda, member, Board of Studies, Natural Sciences, GNA University Fagwara, member, Faculty of Basic and Applied Sciences, MRS PTU Bathinda, member, Governing Body, Sant Baba Bhag Singh University, District Jalandhar. So let us now hear Dr. Dipankar Saha. Over to you, sir.
Thank you, Dr. Mahima. Am I visible and audible?
Yes, sir. Absolutely.
Okay,
audible.
Thank you. And how much time am I having?
Sir, you have 25 minutes.
25 minutes. So, Dr. Pritpal Singh, good morning, sir. Good to see you with the screen. Probably we have not met, but it's a good opportunity for me. And Dr. Mahima in the morning told that whether science is good for the society or bad for the society. Even Einstein was not happy about discovery of the nuclear. So you can understand when the emotion plays a big role while it is that we are going for the exploitation of something. The exploitation of anything is bad. So that is the thing we must have to remember. And overuse of anything is also bad. So that is toxic really for our earth, for our mentally also, and physical also, everything creates that problem. So we have to remain a balance between the internal and an external system. That is important. internal is particularly the emotional aspect. That's why the human beings were created by the God or nature, whatever you call it. And that's why we have to always ask our consciously, our subconscious mind should allow us to do good work. And with this brief introduction, I'm not a hardcore chemist, what the Dr. Ashok Kumar has told, but I'm really happy that I am always with the general topic. And now today, we have to understand what is the landscape chemistry. Really it is in a neglected situation and is being exploited. Could please ask my slides to make the upload, Mahima, because I have already shared.
You've shared? All right. Can I
Yes,
request the backend team to please coordinate with sir and share the slides? Yes.
yeah.
So we're able to see the slide.
So the thing is that make it full screen, please. And the management of landscape chemistry. So because it's a session in the chemistry, and the chemistry is nothing but the bondings. It is not emotional bonding, but the chemical bonding, the ionic bonding, the exchange of the exchange bonding. So even in the chemistry, there is an exchange system. The power exchange system is there that we need to understand and go ahead with the things. So our land is really stressed, and it is really creating problem for our survival for the future. I would like to tell those who are working with it, because I am a man of the environmental science. So I always feel those who are serving the society from it's a passion. This is not a profession, and those who are serving for the environment, they look forward how their future generation will live on this earth. So that is their main focus. So they work in a wider spectrum always, and their vision is always a bigger one. So in that, taking this concept in the thing, can I go to the next slide, please? So why we are going this landscape is not simply a material. We don't try to understand it's not a material, but binds. It is connected us all together. And the affectionate, the bondings are affected, though it is not chemically bonding, affectionate bonding. And in the land is our habitat, that is our society. The land society where we are all staying there, that is our culture, that is our tradition, and that is our heritage, that is our glory, our past, present, and future. Let's consider our land in that direction, then only we will be in a position to live peacefully with our future generation. Can you next slide? I'll go bits fast so that we have some time at the end for discussion. Next slide. So our Bede, the oldest philosophy, also says they are universally acknowledging the contribution of our environment around us. Our development is controlled by the environment. So that the Vedic people also understood the thing, but really we have misplaced those things into our lifestyle. This is one of the aspects we need to consider, and that is everything for our beneficial purpose, and let us not make harm to our environment. Next slide. So in our Upanishad also, if you see, the oldest philosophy also says that the earth or the land, earth is nothing but the land, and water, light, luster, air, they are the components that they are making a balance in our environment. And if you see, we talk about the water separately, we talk about air independently, and we talk about the ether, the vapor independently. But we have to deal our subject if we want to protect our environment in a composite way, integrated way, and any disturbance will lead to a destruction of this human society on this earth. So please try to understand we are in a cycle, we are in a dynamic situation. Earth is always trying to make a balance of its components. We are also should not create any harm to our society. Can we go to the next slide, please? So our fundamental duties also, the regard to the environment, it also says the state, it is our duty. We understand what is our responsibility, we understand, and the duty we forget, and the what is our right we try to everywhere we try to go for. It is our right, we will do it. Not like that. What is our responsibilities and duty? That is our that should be our aim and objective of life also. And also, you have a right to have clean environment. You must raise your voice, become sometimes selfish, and tell our environment is not correct for our survival, for our prosperity. It is required to be rectified, and it is required to be improved, and also try to be a part of the system. And the landscape, if you are coming to the landscape chemistry, it is the rational, it is the affectionate resource. The process of land use planning consists of functions. So that means nature has designed our land in such a way that it can maintain all its balances among us anywhere in the terrain. So the ecologies, microecologies may vary, the vegetation may vary, the biodiversities may vary, groundwater table may vary, the soil composition may vary, but overall they are able to maintain the environmental health in every aspects of our life, whether within the desert or in the air, on the water, in the forest, everywhere. A balance is maintained. Try to understand that situation, how much nature is struggling to make us remain comfortable on this earth. So let's remain comfortable and satisfied what we have with our present situation, and let us go slowly and go along with the environment. That is the science is required at this moment. Let's go to the next slide, please. So land is when it is it's multiple activities are going on in a land. Multiple, like the forest land is the aquatic life system is working, aerial system is working, land is giving shelter to so many things. No lot of bacteria, viruses, all are busy making our food, making our air, making our comfort, making our day and night. Everything they are managing on their own way silently, but really we are not paying attention to our land as request, as desired and trusted by the people. And we are not really learning from our land, our environment, that they all are working together for the need of the ecosystem. Going to the next slide, please. So the prevents land use conflicts are to be avoided. That science we need to understand, discover, and that is the basic. What is the basic chemistry they are following? What is the affectionate pattern they are following? That science is required at this moment. How they are in a position to survive and mingling with our life and associated with our life, associated with our comfortness, associated with our sustainability, those all are really required. So the protects the lands from negative impacts. Always we have to understand whatever has nature has given us, it's all have the beneficial value. Even the toxic plants that also supplies oxygen, we need to understand. And that also grows on the down to the land, and that's why the land is required to be respected wherever we are. We need not to globally. The Bodhi, our Prime Minister, Honorable Prime Minister also says, be vocal at the local. If we are able to work at our local level, we are surely going to get the success. That is the greatest statement. Next slide. So land chemistry, here also you see the land chemistry, it is, we should have life on this earth. The gloriness of our ecosystem is required. Those science is required to be diverted on those areas, how they are surviving without any conflict among themselves, how the bacteria, viruses are useful for our purposes. If we throw waste onto the ground, the land chemistry is getting deteriorated. If we put wastewater onto our river, the water chemistry of the land, the survival value is getting wasted. Even we are throwing the emissions into our atmosphere, the air is getting polluted. If we are burning more things, unwanted things, these are getting deteriorated. So everything we are doing, we are responsible for everything. That needs to understand very well. If we don't understand the situation, if we don't try to understand the chemical bonding they are having, how they are producing food for us, how they are producing oxygen for us, how they are giving shelter for us, those areas the science would be required. Those areas we need to convince people, and we have to make people participate in this program. Those aspects are also very much important. People are working on the laboratory, and if those findings are not transferred to the laboratory in the society, that it is not going to help our purpose. We have to serve our purpose. The science is for the society. So that has to be always, please take help of sociologists along with you, so that it goes to the general people in general for our better survival. Next slide, please. So this is the right hand side picture. This is everything is there, but in a compatible situation. That situation we cannot make anything congested. We cannot make anything like choked. If we cannot, the people are not able to breathe. So people have to understand the land use planning to mitigate the negative effects. That's why it is very much important. Until and unless with the land we start our activities from the land. And again, if it comes to the land for the beautification of land, everything will remain in good condition for our future generations. Then why, next slide. So the slide, soil management is the application, operation, practices, and treatment of the project soil enhance performance of soil. Means the science is required for application and operations, practices, and treatment. Those who are congenial for the performance of the soil fertility. We cannot deny the fertility. We cannot destroy the fertility of our soil. We cannot destroy the soil mechanics and the chemistry. Those are really required. All these sciences are required to concentrate on this aspect. Comfort, we will get everything. Economic value we can gain from, we are also getting from the soil. So please try, let's work. The land use planning is important to mitigate the negative impacts. Always we have to do whatever we are doing, it should not have negative impact on our environment, particularly the soil. And it should always enhance the efficient and effective use, not exploitation. Efficient and effective use, not exploitation, should be our main motto of our science. Next slide, please. So, soil chemistry is an important tool for addressing climate change. We all talking about climate change, and everything. The soil is our buffer. It can absorb everything. If we are able to protect our soil, it can improve our food. It can tolerate temperature. And if we destroy our soil, the topsoil will get eroded. Then it means we have required to apply more chemicals. Please to avoid that part, because if we are not able with this solar energy that is coming from our sunset, that is required to be absorbed in our soil for carbon sequestration process, carbon production process, until and if it goes back to the orbit, it is not going to help our purpose. So let us try to absorb the solar radiation onto our soil. That is very much important for our food and production of oxygen, for our wealthiness. Next slide. So the improved nutrient management, here the sensors is also required. How to improve the low cost thing so that each and every person can make it the soil adaptive. The improved soil nutrient management system through some using some sensor conservation. Agriculture, we should not destroy agricultural field, and that is the important for us, because that is also giving us wealth and prosperity. So those part also need to be even the residual portion should not be burnt into the environment. Let's our scientists try to develop that convert into organic manure, that will save our farmers, our poor farmers, They are the glory of our nation. They should try to understand the value of that organic matter, because nature has produced it. It is not a poison. Then why it should be burned? It should be utilized for our manuring our own farmlands, and that will reduce the burden of buying chemical fertilizer for the soil. So those areas the research is also required. So how fast those silicate bearing residues can be taken to use for our purposes, not for burning, not for power generation, but manuring our own food, our farmland. That is important for us. Next slide, please. So conflicts, that conflict is required to be the conflict. If it is nature has created its own infrastructure, and we need to understand the why nature has created. Try to imagine if had there not been any gradient in the river, with the river would the water would not be flown onto the river. So it is we will not be able to find out the river that the gradient makes the river to flow. Try to understand those things. Nature has created, because everywhere if the river is not allowed to flow, what will happen? Everybody all will go under the water. So nature has designed for its purposes. Why the nature, why the vegetations have been decided? Not only to give out oxygen, but to bind the soil, to make us more strong earth. The nature has created this material. The carbon, what about the coal, oil, what about the food, what about the fuel, what about the fiber, whatever we are taking are carbon only. And this carbon is only possible if we have the soil. So whatever we are burning today in the form of oil or coal or oil, it is nothing but a carbon. It was done by the nature, done by the soil in the past many years ago, and now we are enjoying it. And as on date also, the process is on, and so our future generation have to live with these things. Next slide. So next slide, please. So what we can, simple things are required to, we have to avoid soil erosion, water erosion. Soil should not allow our topsoil to get eroded. That is the muster, that is the sediment that holds the humidity, that does not allow the soil to flow into the air. So that we need to understand. The wind activity is a natural activity. The salt problem is there. Shifting of cultivation is creating problem. Let's try to go with our conventional agricultural system. That is good for our purposes, because that was the thing the nature has created. And if we try to change it, that things are going to get affected. Then the waste has become a problem for us, and after that we will be really astonishing if we are not able to manage our waste. And we have to stay message to all. There is, we nowadays, nothing is a waste, and we need to rediscover what we have thrown into our environment. That is important for us. And we have to, the technology is required, how even in the household family, these waste can be converted into usable material. So that type of information and also the applicated science is also required. So all these things are really good for our important small things, small solve. Let's try everything at local level, and we are going to get the success. Next slide. Next slide. So degradation, excessive use of the real cause of one of the things. It is not only the using excessive chemical fertilizer is creating problem in our soil fertility in the long run. It is deteriorating groundwater quality. It is damaging our quality, and we are earning lot of diseases. We should not apply the pesticide because this is they are killing all our bacteria, viruses, and those who are making us food for us. And if they really killing them, it is not a good sign for our science. So those are required to be understood. That's what decreased soil fertility. Therefore, soil yield is required to be improved if we are able to protect our topsoil. Soil pollution can only lead to water pollution, toxic. If we are able to make our soil clean, then our rivers also will be. Nowadays, all the rivers everywhere, the floods are there because we have encroached the flood. We have encroached our river flood line, river bed, and now we are blaming the river. That situation has to come. Let us not allow or encroach our river portion. Also, we need to think of if how these rivers can be dredged, at least not the bed aspect, but the bottom aspect where the river flows, and the sand mining can be legalized, so that these also likely to help improve carrying capacity of our river, and we will really save ourselves from the flooding in the generation. Next slide. The loss of sand, natural nutrients, it's really going, it is of no use. We have to try to understand everything, so everything comes back to us. That is important for us. Crop cannot grow and flourish in a polluted soil. So we have to think of our soils, the good food, the good brain, but the good prosperity and good society and good India, the best India, like that we have to think. Because soil, we are agricultural based, and we have to pay attention to our soil, and that will bring our prosperity. That needs to be understood by all. But simple tests are required to be created for the people, for our people. Thank you. Next slide. Next slide. So this is the thing just I wanted to tell. The earth soil contains our 2,500 gigatons of carbon. Whatever our body is made up of, full of carbon. Our protoplasm, our cell is made up of carbon. And the carbon is created. Carbon is, we need to be protected. Carbon should not be allowed to be vaporized and available in the atmosphere. Carbon is meant for the soil. It is for the creation of organic material. But the carbon is getting evaporated and made available in our atmosphere. That is not good. We will just try to bring back all our carbon, and carbon is the cause for the climate change. Carbon, because once it is in the atmosphere, it carries heat, and when the atmosphere, air does not know any boundary, so it flows and blows everywhere. So this is the problem. So we are more than 3 times of carbon in the atmosphere, in 4 times of amount stored in our living planets and animals. So let us play attention, take attention for the carbon storage, carbon capture, carbon sequestration is important. Soil carbon that is vulnerable to be volatilized, as I told you, into the atmosphere, in the peatlands, and it may exaggerate the climate change action. Next slide. So climate change resilient, to become climate change resilient, if you want to have adequate rainfall, seasonal rainfall, and timely rainfall, we have to stop, we have to retard the process of climate change. We have to bring down the first option to protect our soil. Let's work become the carbon change resilient, our first option to protect our soil. Let's adopt local technologies for our soil conservation, preservation, and soil fertility. Soil binds us, it is our substratum. Think of if there would not be any substratum, where would have been flown? Only the productive part of the environment, it only gives us food. Take in that spirit. The second largest carbon sink after our seas, all entire carbon is available. The carbon is the fundamental of protoplasm. It is the food, fiber, fuel. Thus, we need to protect ourselves locally by all. Each and every detail is very much important. Absence of human soil erosion has increased, causing siltation of our river. If you want to protect flood, we have to have adequate water, but to improve the carrying capacity of our rivers so that it carry more water. Than the next slide. So carbon sequestration, soil represent the largest terrestrial carbon pool. Carbon sequestration by soil mineral represent promising strategy for climate treaties. I am not telling, the people are telling. If you want to stop retard the climate change activities, you have to start your work from the soil, not later on everything, because soil can absorb and desorb everything. We are not talking about the soil, but we are estimating, calculating everything that is required to be stopped. We have to concentrate our efforts onto the soil. Soil carbon storage can be increased. If the soil is protected, our prosperity, our growth can be improved through soil conservation. That scientist, or I urge my colleague to work on the soil. Conservation agriculture practices such as zero tillage residual, etc., potentially improve carbon storage. Soil amendment, especially the voucher, has been advocated as a promising technology, so that in situ management of our organic management is very much. These technologies are required to be motivated and used, applied in for our purposes. Next slide. So I'm not, this is the stakeholders, all are responsible and all have to share responsible so that we can prepare a integrated soil management program locally. Once we are successful, those success stories must be replicated for our various societies of the sector so that it can grow and ultimately it should advise. Next slide. So initial feasibility study is possible. What is that? Because science is, we know the feasible study, soil management, what is there, posing the requirement for the soil that can be worked out. Deployment of soil degradation survey, where let's not allow to that our soil, no more soil is degraded. That is very important because that is our food, that he will give us the food, and that is giving us, seeking us. engage societal science, scientist, engineer, farmer, everything all together. They must sit together. And I would request the organizer, let's organize one program with our honorable farmers so that we can tell them what we can take their advice for our society. We really, they are the master of how they are managing their soil. We should take on board on them. Next slide. So soil degradation, we have to stop. We have talked. We have to take help of GIS. There are available, ample opportunities are available, and we must create a interdependent nature. So organic farming is very much important. That is our important. Let us not base on any other system, but nature is dependent on advancement. I would be advocating nature dependent advocate. Everything science will give us, and nature will be a burden for the environment. That strategy activist I do not believe. So integration, it's a complex. I request organizer to circulate this thing to among all. Let's have brainstorming on all these sessions. So adaptation. Next slide. Last part one. Go to last part one. Next slide, please. So, no, adaptation is the key. We have to adapt something. It is not only the strongest of survives. It is Charles Darwin. It's not by me. They were the big naturalists who understood the nature. It is not the strongest of the species that survives, not the most intelligent that survives. It is what is the most adaptable survives. It brings the change. So those who can adapt, those who can tell, they are successful people. Thank you so much. Next slide. So this is our versatility of every type of ecosystem. They are protected by our soil. We need to work on these aspects, each and every aspect of the science, so that entire biodiversity, this versatility in the chemistry, versatile has habitat and enhanced support system. Our natural support system improves. Next slide, and thank you so much. Thank you so much. Hope I have completed in time. It was a lecture of about 120 minutes, but I've completed it only in 20 minutes. So thank you so much for giving me the opportunity to all the organizers and those who have there. Thank you very much. Any questions? I would love to answer, but.
Thank you so much, Dr. Dipankar, for such an insightful talk. I now hand over the proceeding to Dr. Pritpal Singh for any comments or otherwise. Over to you, sir.
Respected Dr. Dipankar Saha, participants of this conference, and members of faculty of MMU, and dear students, a very good morning to all of you. At the outset, I congratulate the Vice Chancellor, Dr. Harish Sharma, and faculty members of Maharishi Markandeeshwar University for organizing this international conference on recent advances in applied sciences 2022. I feel privileged to chair this keynote session of the conference with the renowned environmental scientist, Dr. Dipankar Saha, delivering his keynote address on management of landscape chemistry for sustainable development. Basically, this talk of Dr. Dipankar Saha is an eye-opener for the policymakers, for the public, so that we can take timely action for the preservation of environment. We are all aware that India is the world's 7th largest country area-wise, and it is 2nd largest country population-wise. India is characterized by immense diversity in climate, topography, flora, fauna, land use, and socio-economic conditions. During the past few decades, India has experienced remarkable land use and land cover changes, including deforestation, cropland changes, and urban expansion. So after World War II, India was facing a severe crisis of food, and it was at the brink of near famine when in the late 1960s, the Green Revolution was set in by the efforts of the scientists, and this has alleviated hunger from the country, and from a food deficient country, we have become a food surplus country. It has raised incomes of the farmers and contributed to declines in the infant mortality rate. So the urge for food sufficiency was so strong that environmental issues and sustainability were kept behind. The Green Revolution adversely affected the agricultural biodiversity, wild biodiversity, and the environment. Wheat and rice rotation circle that has contributed to a number of problems, and that has also led to the increase in the carbon in the atmosphere over the past 6 decades. Poorly regulated and excess application of nitrogen fertilizers, especially urea, resulted in emissions of nitrous oxide, a potent greenhouse gas that also led to pollution. Basically, by the adoption of this wheat rice cycle, we moved away from the cultivation of legumes, which added a lot of nitrogen to the soil, and as a result, our dependency on the nitrogenous fertilizers increased. One of the main challenges facing India today is to develop strategies to sustain and improve living conditions of a growing population and using the land resources in a sustainable way at the same time. We must protect our landscape for sustainable development. Dr. Saha illustrated in his keynote address all the points which require action, what are the problems we are facing, and what are the solutions for those problems. And we all need to work together to alleviate these problems. Whereas we are having a lot of food grain production, but with the passage of time, the underground water has been extracted at a very large rate, and we are facing crisis in a number of states. So water crisis is going to be a major issue in India in the coming days. So we have to shift to agricultural practices like horticulture, which require lesser amount of water so that we have sufficient water for the generation to live and we have a sustainable development. Organic farming can increase farm productivity and repair decades of environmental damage, but there is an opinion among the farmers that the organic farming will decrease the productivity. So we will have to adapt to this organic farming. Similarly, scientific solid waste management techniques like composting, vermicomposting, landfilling, and incineration must be adopted instead of dumping the municipal waste in open, which is the practice in most of the cities. In many of the cities, the government has tried to install the solid waste management plants, whereas they are working in some of the cities very effectively, but in some of the cities they are not adopting these solid waste management techniques. Future strategies like mass awareness, use of soil management techniques, more sampling and testing with mobile labs, use of organic nutrients, and efficient waste recycling techniques will also help us to accomplish this goal. Food production goals have to be met in ways that alleviate poverty, improve nutrition, and conserve the environment. Interactions among the challenges require that they be addressed in a concerted way. The future we want lies ahead if we are willing to take the necessary action and implement integrated landscape management around the world. And I hope this talk by Dr. Dipankar Saha is an eye-opener, and we should work together to aware the public and the farmers so that we can adopt the sustainable agricultural practices. And I am very elated that Dr. Dipankar Saha has given a call to involve the farmers, because the research that we are carrying out in our labs, that is not reaching out to the masses. So it is a time to involve all the scientists and the public so that we can collectively work for the environment. Thank you.
Thank you so much, Dr. Pritpal, for your words of wisdom. Thank you, Dr. Dipankar, for an insightful talk. We now move on towards our next session. I would first like to give a special thanks to Professor Vijay Thakur, who's joined in straight from UK. I'm told it's quite early there. His session was scheduled from 5 to 5:30 a.m. in the morning, and I've seen sir waiting from last 20 minutes. Sorry for the whole, sir, but we really appreciate your presence. Thank you so much. So, moving on, let us now collect the fruits of knowledge from our very own eminent speaker 6 and the preceding session chair, who have joined us today and made time from their packed schedules and have kindly consented to preside over this discussion. Let me quickly introduce you all with our dignitaries of discussion 6. The keynote speaker for this session is Dr. Vijay Thakur, Professor Biorefining and Advanced Materials Research Center at Scotland's Rural College, SRUC, Edinburgh, and also holds an adjunct professor position in the Research School of Polymeric Materials, Jiangsu University, China, visiting professor at Shiv Nadar University, India, and a visitor at Cranfield University, UK. Dr. Vijay has previously held faculty positions at Cranfield University, UK, Washington State University, USA, and Nanyang Technological University, Singapore. Sir has published over 400 SCI journal articles and holds 1 US patent. He has more than 20,000 citations with H index of 82 and I-10 index of 257. His research activities span the disciplines of biorefining chemistry, chemical engineering, manufacturing, material sciences, and nanotechnology.
You can stop it. It's too much. Thanks very much.
So I would like to introduce you in a proper manner so that our audience is pretty aware about the accomplishments you've done so far. So carrying on, material sciences and nanotechnology, as well as all the aspects of advanced materials. He has been a PI co-I on several projects sponsored by BAE Systems, EPSRC, Royal Academy of Engineering, UKIERI, Innovate UK, and others. He is the member of the editorial board of several SCI journals. Dr. Vijay Thakur has published over 300 SCI journal articles, 2 patents, 52 books, and 45 book chapters in his academic career. In the year 2021, he was ranked 122nd in the world's top scientist list in the polymers field that Scopus database has compiled for career-long impact, and highly cited researchers list 2020-2021 by the Calrivate's Web of Science. Sir is also an editorial board member of over 20 plus SCI peer-reviewed international journals and a member of scientific bodies around the globe. The session chair for this session is Professor Adesh K. Saini, Head R&D at Maharishi Markandeshwar deemed to be University, Mulana. With a research experience of almost 20 plus years, Professor Saini holds a PhD degree from University of Delhi and postdoc at the National Institute of Health, USA for 5 years. Ex-Dean of Faculty of Sciences and ex-Director of Himalayan Research Center at Sholini University. Sir is currently heading R&D at MMDU. He has almost 95 publications in Scopus Index journals and 60 patents filed and 14 granted. He has received almost more than 3.25 crore grants from DST, Ministry of Environment, Forest and Climate Change, DST MBI Indo-New Zealand grant. He works in the area of nanotherapeutics, redox biology and genetics. Let us now hear Dr. Vijay Thakur. Over to you, sir.
Thanks, Mahima, for the nice introduction. It's too much. And thanks, Professor Sani, as well, the organizer, for the invitation. And it's always a great pleasure, although in very morning. So, can you see my screen? Let me see how.
Very good morning, Professor Vijay.
Good morning. I don't know how to share it. This is the first time I'm using
so
it.
I guess in the bottom you will find some share option, right? So click it and then you can share.
You need.
So you see a share option
Yes.
the bottom. If you click on that, you'll have to click on slides. You'll be able to share the slides if you've already added it, or maybe you can click on share screen and share the entire screen.
Share screen. Yes.
You have an option for sharing the screen also.
Can you see my screen now?
So far, no, sir. Maybe it will take another 1 second if you've already displayed it.
I have done it. Let's wait.
Yes,
It's coming, I
also,
guess.
we can see it, sir.
So you can see it.
Yes, sir.
Okay, thanks again. And this talk is more generic about how we are combining sustainability and functionality to develop new material. Not much more science, because I understand you might be over-exhausted over the last day and today as well. So a little bit about SRUC. I am sure you might not have heard. So did I until I joined. So SRUC is a premier agriculture and life science institute that sits within the University of Edinburgh. We do almost anything, but not everything, starting from agriculture science, biotechnology, and now these days more on sustainable chemistry. I do hold my current links with the Cranfield University, where I am still supervising 7 PhD students. And research direction: over the past 15 years, my research has been focused on the core theme of development of sustainable materials for the future. We have been combining different chemistries and materials to develop high value materials for engineering applications, and nowadays we are also focusing on biomedical applications. Currently, we are trying to merge three different directions with core theme of sustainability. We are developing different types of sustainable monomer, polymers, and material. Then we are also trying to incorporate self-healing capability in the materials, especially learning from nature, where we are trying to replicate the natural characteristics among different types of material for both biomedical and aerospace application. And in terms of manufacturing, that is the most hot topic these days, and one of the way to have more employment as well as develop next generation materials. Here we are exploring the use of additive manufacturing, commonly known as 3D or 4D printing, bioprinting, and nano manufacturing, where we are mainly focusing on electrospinning and another manufacturing techniques. If I talk about materials we always come across every day in our life, and in fact, there are more than 17,000 of materials that has been used or being used for engineering application, and this number is increasing day by day, starting from our household to biomedical to aerospace application. Everything depends upon the need, what type of materials we need, and what are the intended applications. And along with materials, we hear a term called sustainability or sustainable materials in particular, if I have to be precise. So what really sustainability is? Different people define sustainability in different way depending upon from which discipline they come, science, engineering, society, or any other discipline. But according to World Commission on Environment and Development, sustainability is anything that meets the needs of today's generation without compromising the need of tomorrow's generation. And luckily, anything green or vegetation we see around us comes under sustainability, and thereof the materials developed from these resources. So we have been making use of different types of biomass-based material, whether it is waste material or valuable material such as vegetable oil, that is a key component of Asia Pacific food habits. We have been exploring different types of material that sometimes don't compete with the food chain, or maybe they are more economic or in abundant amount. Say in US, soybean oil is in excessive amount, and that has been used for development of new sustainable polymer. I will come into that shortly. Then another area is how we can use different waste materials. So we have been using different waste, whether they are natural or artificial, and developing different types of sustainable products. And why there is need of sustainable materials, and why we need to combine sustainability and another engineering perspective. The reason or answer both are in the same coin. It's in front of us. There was recently a news that confirmed that today our oceans have more plastics, they are mainly at micro level, than the fishes, and by 2050 most of the population will be increasing in all the countries, and especially in Asia Pacific and South African countries, there won't be any food. So we must have to tackle the issue so that we don't raise our environment, because our environment is also temperature. If I talk about temperature, it's rising almost 1 degree per decade or something like that. So you can imagine we are already seeing the devastation caused by these so-called different scientific effects, especially tsunami and so on. We have witnessed these in India, and one of the key reasons for this has been the destruction to our environment caused by man-made activities. And if I come about the development of new sustainable and smart materials, it reminds me of Bill Gates' statement that said that we always overestimate the change that will occur in the next 2 years and underestimate the change that will occur in the next 10 years. And both our sustainable and smart materials combined with biotechnology and advanced manufacturing, they fits within this domain, because if properly designed and executed, these materials can solve some of our problem. And in this direction, we have been developing different types of sustainable materials, say hydrogels for biomedical, tissue engineering, water treatment, as well as sustainable composite material for automotive and aerospace application. In terms of smart material, we have been developing piezoelectric and dielectric material both for energy harvesting as well as energy storage applications. In terms of self-healing, as I mentioned earlier, most of the engineering material during their life cycle undergoes some sort of damage. That is really very difficult in terms of biomedical and aerospace application, because you don't have another chance. In this case, suppose we are flying, if something goes wrong, we cannot immediately sort it out, and you know the result. Similar thing happens with the person having a lot of health issues. So we have been working on development of new chemistries and materials for self-healing structural composites. There are different chemistries starting from photoresponsive shape memory to capsule-based approach for structure application. We have been focusing on microcapsule-based approach because it also embeds good structural and mechanical properties. One of the key issues with this technology is the cost of precursor, especially say Grubbs catalyst, is really very high, sometimes higher than the materials we do. So we have been working on development of new bio-based capsule where both the core and the cell are from bio-enabled sources. We did some preliminary study and compared it with our well-established work on DCBD, and we found that although the properties are slightly lower than the existing, but we think it can be improved, and we are trying to see how we can improve these mechanical properties and compete with the traditional DCPD-based microcapsule. Because if we are able to do it, then I think we will be able to solve a great problem, and we are working on this. Similarly, we are developing different types of self-healing materials for biomedical application as well as some of electronic applications. Then one another area we are working on how we can engineer the polymers. That has generally remains limited to biomedical application, but not much work is carried out for energy storage or energy harvesting application. And one of the application we have been targeting is dielectric capacitor for energy storage application. Traditionally, ceramic-based capacitor has been used, although they have very high dielectric constant, but their breakdown strength is very low and it's very difficult to process them. They need very high temperature for processing, sometime more than 2000 degrees Celsius. Polymers are explored for this application because they have very good breakdown strength, good flexibility. You can carry out printing or large scale manufacturing. But problem is polymer generally don't have a high dielectric constant. So generally the approach is to combine both the materials, and it was believed that the combination will lead to higher mechanical or electrical properties, but the results were not so good. So we adopted another approach. We tried to engineer the polymer. Here I am showing the example of PVDF, which is one of the most hydrophobic fluoropolymer, and we engineered it with the aniline instead of making it a conducting polymer, that is the general chemistry where you do graft copolymerization of a conducting monomer system. But here we were able to incorporate nanodomain through our DELP technology, and we found that the dielectric constant in our case was more than 1100. This is one of the highest dielectric constant reported for any material so far, and this technology has been already transferred to industries few years back. And the slim electronic material, you see, they involve the SIM, or you can say capacitive system or flash memory system, developed by us. And also based upon this work and some other work in the same direction, we are invited to summarize the recent advances on fluoropolymer-based material. And if you are interested in exploring PVDF for different applications, you can have a look for this article. Then piezoelectric material. These materials are really very key material for defense-related application, and we have been developing different types of smart material or self-sensing material. I won't go into more detail because it was more of a defense-sponsored project. But we are also exploring the use of these piezoelectric material for structural health monitoring or human health monitoring. Idea is to develop some sort of cell-powered sensor that can send a signal if someone at home is sick or having some issues, and we can directly get a signal on our phone that there are some issues. And also obviously we can call someone in the family or neighbors to see what is happening in this direction. There are some development where piezoelectric nanofiber and other types of materials are being developed. Another direction, sustainable materials, that has been always very close to my heart. Sustainable materials, we are exploring the development of different types of functional materials from cellulose, gum, pectin, chitin, alginate, and starch. And one of the interesting thing about these natural polymer or sustainable material is their functionality. You can easily engineer them to incorporate functional group that better suit our applications. And that one of the best property that makes them unique when compared with the traditional materials is their biodegradability, sustainability, and inherent environmental properties. And if I talk about how we are developing different types of sustainable chemicals and polymers, in everyday life, we can see that any materials we use in transport or automotive application, they have unsaturated polymer polyester resin as one of the components that generally we use as adhesive in paints or so on. And one of the components these material involve is styrene. And styrene is nothing but a polymer, and all the ball pens we use, that is also involve a significant amount of styrene for making them up. And to address this issue, we have been developing both the alternative of styrene as well as this traditional unsaturated polyester resin. Here is soybean oil, the chemistry. I won't go into more detail, but here is the final product that we got. As you can see, it looks really nice, but it is highly viscous, similar to their synthetic counterparts. So we also came across that we need a reactive diluent. Traditionally, styrene has been used as a reactive diluent because it has low viscosity, provides good mechanical characteristics, reactive enough to polymerize with another system. However, the disadvantages are highly volatile, non-renewable, hazardous air pollutant, and in California state, now it is mandatory to mention that it is a carcinogenic chemical if you are involving styrene. So you can understand the grave side effect of this polymer. And if I talk about how we are being infected by its use, although the automotive industry, or you can say composite industry in general, make use 9% of styrene, but accounts for nearly 80% of styrene emission because it is really highly volatile. So in everyday life, knowingly or unknowingly, we are always inhaling styrene or such sort of toxic chemicals. And we have also been working on development of new sustainable monomers. Here is the example where we have developed new bio-based monomer from plant lignin and valine. Here is the final product we get, and someone who works with styrene, he can know the nasty smell of styrene, but the material we developed, it's really like a vanilla fragrance, and I can say with confidence that any PhD student working with this chemical would like to work. He won't want to get out of the lab because it's such a nice chemical. And if I talk about the volatility, you can see here the styrene, it just evaporates in 5 minutes. Almost whole styrene evaporates at 30 degrees C. The experiment we carried out in the lab, and the material we develop, you can see it just so 5% weight loss for nearly 9 hours. This is what we carried out the experiment for maximum time. Similarly, we did viscosity analysis. It is quite good as compared to the traditional synthetic properties. So is the mechanical characteristics. Also, we have been developing new monomers from our traditional material clove. This is a historical being used in Indian system, whether it is for biomedical application or for food related application. However, in this case, we try to make new type of monomer from this system, and it also showed good performance. Also, as I said earlier, we have developed different types of polymers from soya flour. So we did also made use of soya flour waste that is generally used as a feed in US or in China. And one of my PhD students way back in US, he developed a nice adhesive, and now they are exploring its use for industrial application as a potential alternative for traditional phenol formaldehyde or succinol formaldehyde resins. Also, we are working on bio-based material. As I said, we are exploring the use of chitin for different applications. Mainly, we are working on nanofiber and nanogel, both for biomedical and water treatment applications. During this pandemic, we did start some work on different antimicrobial materials and nanocoatings, where we are also working very closely with Professor Ades. In fact, this is Professor Ades' expertise, but not mine. And we are also developing new type of coatings for antimicrobial application. Recently, we did develop new coatings for leather-based materials, and this work was highlighted in Chemistry last year. Similarly, we are trying to develop different types of smart textile, in which we are embedding new piezoelectric materials as well as antimicrobial characteristics. I won't go into more details in the time limit. Also, we are exploring different types of green chemistry approaches for the development of new anti-infective materials. Here you can see one another area that is also very interesting to us is develop new material for osseointegration applications. Here we are trying to develop new bio-based coating, because one of the problem with traditional implant is sometimes our body does not accept those materials, and after 5 years or 10 years, there are always significant problem related to the infection. And in this case, we are developing new coatings where we are making use of cellulose-based material, trying to incorporate new nanomaterial to enhance the mechanical characteristic as well, so that to meet the traditionally used materials. We are also transforming different materials to nanoscale, especially cellulose-based materials. And we are using the cellulose-based material both for packaging application, biomedical, and these days for energy harvesting application, especially in wind turbine blade. Generally, wind turbine blades are made up of glass fiber-based material, but one of the problem with glass fiber is their recycling. As of now, there are no issues with recycling because their lifetime is generally 40 to 50 years. But if we see 20 years down the line, there will be huge problem all over the world how to recycle these materials. So we are trying to incorporate different types of cellulosic nanomaterials so that we can partially replace glass fiber-based wind turbine, although we cannot replace 100% because then we have to compromise with the mechanical property, as well as these materials are more sensitive to environmental applications. One of the example I want to say here is generally we have the understanding that nanomaterials so enhance mechanical properties, if I have to be specific, but recently we have found that it is not really the dimension that gives you the higher mechanical properties, but there are another parameter, how you manufacture it, how you control the another parameters. Here we have so that at 40% MCC, we get better properties than at nanoscale. And if I talk about life cycle analysis, that is an important parameter that decides whether we are contributing to net zero emission or not, or it's a totally sustainable product. They have come into play. And if we see the energy involved in this case, there is no use of using this material if we go to nanoscale, because then it is better to use some sort of synthetic material. But if we stop at microcrystalline level, we can significantly curb the energy use as well as optimize our sustainability parameters. So similarly, we did optimize two different techniques. One was master batch and solvent casting. We found very good result with master batch. That is really very good for engineering applications. I won't go into more detail now. Then another work we have recently carried out, we have transformed this hemp waste that is considered in India especially culprit, and it's in UK or Western country. Also here farmers need to take the license to cultivate hemp, because hemp is really a very high value medicinal plant, but its fiber or straw is generally burnt or used for lower end application. Here we have transformed into new sustainable foams, and we did compare its properties with the traditional wood-based foam. All the characteristics were similar, mean the material can compete with the traditional wood-based material with having inherent environmental as well as economic properties. The result was highlighted in several media a few years back. And if you are interested more on learning about bio-based nanomaterial, nanocomposite, and their application, you are more than welcome to go through this article, and I will be happy to share as well if you don't have access. Then another area in terms of manufacturing, we are developing different types of materials, starting from sustainable to functional, using printing technique, where we have been working on 3D printing and 4D printing. We recently finished one UKRI project with BIT India on 4D printing of materials, where we have been developing different types of sustainable polymer and then obviously printing it through our medium. And another area we have been working closely with industry is needle-free electrospinning. The problem with traditional electrospinning technique is you can prepare only small sample at lab. However, through needle-free electrospinning, we can prepare large enough specimen to be used at industrial scale. And this work was carried out in close collaboration with industry partner as well as partner from Riga Technical University. Here we did involve the component from natural resources, and we did prepare some nice scaffold for biomedical application. Also, we are making use of curcumin for developing smart dressing, especially for burning application, as well as embedding some sort of PVDF based smart piezoelectric nanofiber for structural health monitoring. And to summarize, in terms for a sustainable world and sustainable environment, we must use that has not been used so far, and we must ensure food security whatever we do, so that we can move from a fossil-based economy to a bioeconomy. And on a separate note, we are also welcoming submission to several new journals, and you are more than welcome to submit your good quality paper to the journals. And at the last, there are many people who have contributed to the work so far. I cannot name each and everyone. So thanks to everyone who have helped in the journey so far. It includes Professor Ades and his group, Dr. Samarjit from MMU, and then many other from India and overseas. And lastly, the funding agencies who have generously funded our work. And thank you very much for your time. I will be very happy to answer any question, obviously, if I can. Thank you.
Thank you so much, Professor Vijay. I hope I'm audible.
Yes, yes, yes.
Yeah. So thank you so much. So I hope everybody agrees that smart material technology enables us to adapt to environmental changes and by activating its functions, right? And multifunctional materials which you talked about, there are sort of materials which can be activated by some sort of electrical stimuli or something like that, right? And they are very helpful. So thank you for your beautiful talk. And research and development group, Professor Vijay is helping our faculty members as an advisory board member also in our R&D cell as well as other part of the things, right? So thank you so much for joining here for today, and you gave like wonderful talk. So I don't know much of the chemistry, I know the biology. So I always feel like how to connect to this biological part. So we have a couple of queries regarding a couple of things. So we are always talking about how we are going to see the quality of the material which you develop for its sustainability, right? But I'm also concerned about the process which we use for developing a material. We are always into the field that we want to see the sustainability of the material, but I would say sustainability of the process. So I want to ask you like how you think a process should also be sustainable. I mean, the waste it is going to generate, something like that. So I mean,
in this case, this advanced manufacturing technique, especially printing, this 3D printing or 4D printing, it can save significant amount of energy as well as waste, because traditionally when we used to develop different type of material, especially composites, we make use of significant amount of polymer resin as well as reinforcement, and then we need to sort out different types of material. Say for example, if I talk from a layman term, if you are making a door, you can see a carpenter making a door, he makes a lot of waste material, right? Yeah. Through our advanced manufacturing technique, simply 3D printing, you can exactly print the same material, but you don't even need to cut 1 inch of material. So that is more about related to processing.
So my next question, I mean, is there. So you talked about it looks very nice and interesting, that nanoscale versus this microcrystalline scale, right? So yeah, we generally forget these kind of things. So whenever we do some experiment, we always want it to be the nanoscale. And it could be possible that at micro scale, the activities are really good as compared to the nanoscale. So you don't have to go to the nanoscale. So what are your take on this? I mean, you showed one data over there.
Yes. So I cannot talk more about another material, but I can talk about sustainable material or cellulose-based material where large of significant amount of energy is used when you are processing it. Pre-processing, you need to extract different types of semicellulose, lignin, and then do another mechanical processing to come up with the so-called nanoscale material at cellulosic or nanometric level. In that case, you involve significant of energy. And when we do the life cycle analysis, that is now the gold parameter to see whether your material is sustainable or not. In that case, when we go to nanoscale, significant amount of energy is used, and it is more than the traditionally available, say, glass fiber or carbon fiber. Then there is no use of making this material when you are making huge loss to our environment. In that case, it's better to stick to synthetic material. So I'm not sure about another material, say ceramic nanomaterial or inorganic nanomaterial, but in case of cellulose-based nanomaterial, we have proved it that in some cases, especially for mechanical application, because in mechanical properties, we have shown that we can get good properties at microcrystalline level. So this need to be further explored for another applications. Maybe we need to see whether this type of microcrystalline particle can be used for implant, see how is their mechanical strength, and then how they biologically reactive, and you are the best person to explore that. Yeah. But this is something need to explore for another application out of these automotive applications.
Yeah, thank you. So the last question is like you talked about this hemp, right? So you developed a new technology and it has a lot of potential.
Yes.
So I'm thinking like in India we have a problem of stubble burning, right? So a lot of biomass is there, and we generally burn that, and creates an additional problem. of health, right? So what are the properties in hemp which you feel like could be looked into these straws, which could make them also useful and give you a dollar value to these things, so that the farmers will not burn it and they will get something, right? So
I think if I have to talk from cellulose or lignocellulose perspective, hemp has more cellulose, while this straw, it has more lignin. So it can be used slightly for more low-ended application. It cannot be used for fine structural application, but it can really be used for, say, biohydrogen application or this type of nanocomposite or structural composite, where you don't care much about the higher mechanical properties.
Okay. Thank you so much. And these are all questions from our side. So Mahima, if you have anything to say. So thank you, Vijay. Thank you so much.
Thank you so much, Dr. Vijay, for such an insightful talk. Thank you so much, Dr. Saini, for your words of wisdom. We shall now proceed towards the oral and poster presentation. So we will have that in a separate platform, and after a while, around 3:15 or so, we will meet again for the valedictory ceremony. So stay tuned. Thank you so much, everybody, for joining in. Have a great day. Thank you.